All right, let's dive right in. We're going on a bit of a journey today to figure out how raw, messy data is actually transformed into real, actionable business decisions. And spoiler alert, it does not involve magical algorithms just pulling answers out of thin air. Welcome to This Explainer. Today, we're demystifying a world that honestly usually feels hidden behind crazy complex math and endless lines of code. We're going to walk through the actual step-by-step methodology used to pull vital knowledge out of mountains of information. So start by picturing a data scientist. Like, what actually comes to mind? For a lot of us, we get this Hollywood image, right? A lone genius in a dark room, furiously typing out complex machine learning code all day, just waiting for the computer to spit out some million-dollar answer. But as you're going to see, the reality of extracting knowledge from big data is way more grounded and, frankly, a lot more interesting than that stereotype. Okay, get ready for a massive reality check. Look at this breakdown. A staggering 79%, yeah, almost 4/5 of a data scientist's time, is spent literally just collecting, organizing, and cleaning up the data. Only 4% goes to actually training those famous flashy algorithms. So to truly understand how data drives our modern decisions, we absolutely have to look at the entire life cycle of a project, not just the fun math at the end. To help us do that, here's our detective's case file, basically mapping out the 6 standard steps to solve a business mystery. We'll be walking through misconceptions about data science, understanding the business goal, gathering and prepping data, using models to discover patterns, evaluating results for accuracy, and finally, deploying solutions in reality. Let's start with step 1, misconceptions about data science. Let's strip away the buzzwords and figure out what we're actually talking about here. It is super crucial to understand that data science is way broader than just machine learning or data mining alone. As you can see from this definition, it's a whole comprehensive set of principles and processes. The ultimate goal isn't just to find a cool pattern in the numbers. The goal is to extract non-obvious, genuinely useful patterns that actually improve human decision-making. Literally, if it doesn't lead to a better business decision, it's just numbers sitting on a screen. Which brings us to step 2, understanding the business goal. And honestly, this is where so many projects completely fail before they even start. Because before a single line of code gets written, you've got to define the problem. Now look at the arrows in this standard methodology model. The process is not a straight line at all. It's a continuous loop. You're constantly jumping back and forth between understanding what the business needs and evaluating what the data can actually do, tweaking your approach based on what you find along the way. It's really all about balance. We have to carefully weigh what the business actually wants to achieve against the harsh reality of what our current data actually allows us to do. Like, say you want to predict exactly what a customer will buy next year. Okay, great, that's your business understanding. But if your data only shows what they bought a decade ago, while your data understanding is telling you loud and clear that you've got a major gap. The data scientist is really the bridge between that business dream and the data reality. All right, let's move into step 3, gathering and prepping data. Remember that crazy 79% figure from earlier? Well, this is where all that time goes. To get our raw data actually ready for analysis, we have to meticulously hunt down errors. I'm talking about finding bizarre outliers that could totally skew the results, figuring out what to do with missing values, without just faking the information, of course, and merging data silos. That means dragging information out of the marketing department, the sales floor, and customer service, and combining it all into one massive central table. It is a lot of heavy lifting. But it's not just about cleaning, it's about engineering. Take a look at this example with BMI and diabetes risk. Sometimes the true magic of data science is designing completely new combined features. Just looking at raw height or raw weight on their own, that might not show a clear pattern for diabetes risk. But when human intuition combines them into a single metric, body mass index, bam, a much clearer predictive pattern emerges. This right here is exactly where human expertise guides the machine. And only after all that rigorous prep work do we finally reach the aha moment. Section 4, using models to discover patterns. This is where the algorithms step in. When people hear the phrase machine learning model, they usually picture some massive sci-fi artificial brain. But take a look at this decision tree for classifying spam emails. It's remarkably simple. It's basically a logical step-by-step branching path. Does the email have a suspicious word? Yes or no? Does it have an attachment? Yes or no? The algorithm is just rapidly testing thousands of these little paths to find the one that gives the most accurate conclusion. It's kind of like a hyper-fast game of 20 questions. And depending on the specific business mystery we defined way back at the start, we run specific algorithms to solve it. If we want to group similar buyers together to tailor our marketing, we use something called clustering. If we need to flag weird credit card transactions, we use anomaly detection. Or if we want to guess if a customer is going to cancel their subscription next month, we build a predictive classification model. You simply match the tool to the goal. Now on to step 5, evaluating results for accuracy. Look, once the computer builds a model, we definitely cannot just trust it blindly. We have to rigorously test it against reality. Because evaluating a model, it is not just a math test. It is a measurement of real-world business risk. Look at this medical diagnosis scenario. A false positive, like telling a healthy person they might be sick, well, that might just result in them getting an extra blood test. Lower risk. But a false negative? Sending a sick person home because the model confidently said they were fine, that is incredibly dangerous. A truly good data scientist always evaluates a model based on the real-world cost of its specific mistakes. Which brings us to the absolute golden rule of evaluation. Never, ever test a model on the exact same data you used to train it. If you do that, the model might just be memorizing the past, kind of like a student just memorizing an answer key, rather than actually learning how to solve the problem. We have to make sure it can generalize and make accurate predictions on fresh data it has literally never seen before. Art. Assuming our model actually passes the test, we hit the final stage. Step 6, deploying solutions in reality. Because a brilliantly accurate model just sitting on some developer's laptop is totally useless. Deployment is all about taking that predictive power and wiring it directly into the company's daily operations. As this quote perfectly highlights, true integration means taking a process, like identifying potential fraud, from a human spending 6 weeks investigating down to a system generating a direct, real-time alert the exact second a card is swiped. That is your tangible return on investment right there. But the job still isn't over. Models are built on what's called the assumption of constancy. Basically, this idea that the future is going to behave exactly like the past. But we all know the real world changes. Customer habits shift, economies fluctuate. This causes what data experts call concept drift. So we have to constantly loop back, monitor our deployed solutions, and retrain them. Because what was true yesterday might absolutely not be true tomorrow. So what does this all mean? We've seen how messy data transforms into sharp decisions. But remember this, models only reflect what we feed them. If our past data is full of errors, biases, and flaws, well, our automated future is going to be flawed too. As we rely more and more on data to run our world, our responsibility to gather accurate, unbiased evidence has literally never been more critical. The detective work, it turns out, is never truly done. Thanks so much for joining me on this explainer, and I will catch you in the next one.